Well, let's take it a quick example look at inheritance based on some of the previous code that we've implemented. So one way we could use inheritance is by implementing a queue by deriving from list. So we previously implemented a queue by placing a list object inside of a queue object. But alternatively, we can just inherit from the list object. So what we do is this. We say that class Q inherits from list, or is derived from class list, right? And so we have to have this syntax class Q colon. The colon tells us that we're about to request an inheritance from another object. Then for now, we just always make this next word keyword public, and then the name of the object or class we're inheriting from, list in this case. And this is our previous list object we implemented. The one that's not based on a template, just kind of the old original singly linked list code. And then we have our 4 interface functions for our queue: push, pop, peek, and empty. So inside of a list, we have an append function, right? So when I want to push onto the queue, I want to push some item. What that is in terms of a list is append. And so since my queue inherited all of the member variables and member functions from list, then the queue object is the list object. It contains all of those pieces. And so we don't need to ask an object to do the append for us like we did in our previous implementation of a queue. All we need to do is say, call the member function that's contained within the list, called append, and append the item to the list. So this is calling a member function within the queue object now, because append comes from list, is inherited from list, but is part of this object. Okay, likewise for pop, we're going to remove, when we appended, we added to the tail of the queue, the tail of the list, and now when we pop, we're going to remove from the front of the queue, from the front of the list, and we can do that using remove after by passing in a null iterator. And so we just call the remove after member function. And then for empty, now here's the thing. We can't directly access head and tail because they're private within the list class. And so when we inherit list, head and tail are private and we can't directly access them from our queue object. But we can call its public member function empty. And so in order to say that, oh, there is an empty function inside list that we want to call, actually I didn't, inside list that we want to call, we can write list : empty. Now the reason I have to put the list : here is that queue also has an empty. And so if I just wrote return empty, I would actually be recalling itself recursively. And so to avoid that endless recursive call, I need to specify that I don't want this empty, the empty in queue. I want the empty that I inherited from list. And so we just specify out the queue, I'm sorry, the base class name, list : in front of the function to say, oh, I want the member function from my base class, not the member function in this class. Okay, so that sums up our how we could implement the queue by deriving from list. You notice that's a pretty simple implementation because we inherit so much from list, there's very little we have to do inside the queue object. We just have to, when we push, we need to call append. When we pop, we need to call remove. I didn't show you peek, but that one's pretty simple. We just need to get an iterator to the first element and return a reference to that first element. And then empty, we just need to call the member function from the base class.